Everybody, this is the notes for week 3, Algebra 2 Trig, talking about dividing polynomials. So, I'm going to try to do this all in one video, but I'll try to put some time links on it so you can jump to the part that you may need more. But when we talk about dividing polynomials, we got a couple of things. We got dividing by a monomial, which is this example 1 that you see in your notes. But basically what that means is we are dividing by one term. Remember, terms are separated by addition and subtraction. So we're dividing by one term. So basically what we do, we take each term in the numerator and divide them by that one term from the denominator. It was subtraction in that numerator, so we're going to keep it. Depending on the numbers, the powers of the variables, there might be some quicker ways to do this. Thinking about canceling out your greatest common factors, factoring out everything you can from the terms in the numerator, but sometimes it doesn't work out that way. So this is just the best way to go about it. So in this first term, 9 divided by 3, m cubed divided by m squared. Basically, we're just simplifying. 24 divided by 3 is 8. M squared divided by m is m. And that is all she wrote, dividing by a monomial. The next part of dividing polynomials is this idea of long division. Okay, this is example number 4 from your notes. It has a variable k in your notes. I didn't want to write k's, so I changed it to x's. But using long division, just like you learned back in 3rd, 4th grade, whatever it was, dealing with numbers. It's the same process, but obviously there's a little bit more to be thinking about. So we are dividing by x plus 5. So we're going to put that out in front, x plus 5. Inside of this division symbol, we put our polynomial, the one that we're dividing into. Now, with long division, it is not necessary to have a placeholder. It's just really convenient, and it's going to help you not make some mistakes. So notice how we don't have an x squared term. All right. So x cubed. And I'm just going to put plus 0 x squareds. It's a placeholder. It's not, again, not needed, but it's helpful. Very helpful. And it's not needed for long division. I should clarify that. All right. So that's our setup. What we do is we look at our first terms. So x cubed, x, those are our first terms. What would we multiply x by to get exactly our first term of x cubed? So that's x squared. That's how we figure out what goes up top here. This is going to be our quotient, our q of x polynomial, basically the answer to the division. So once we have this from looking at the first terms, we take this x squared and we multiply the entire divisor by it. So x squared times x cubed, x squared times 5, and this is where that placeholder comes into play. Once you do that multiplication, we are subtracting that. Now, I'm going to put parentheses around it, not vital, but again, really convenient to help you avoid mistakes. We are subtracting like terms, x cubed minus x cubed. That's 0. It should be every time. 0x squareds, we are subtracting 5x squareds, negative 5x squared. If you didn't have that placeholder, guaranteed somebody's going to make a mistake, and it's going to happen frequently. So use the placeholder. Once we do that subtraction, just bring down the rest of the terms that we didn't mess with. So minus 17x plus 32. And we repeat. We look at our first terms, x times something, to get us our first term of negative 5x squared. So that's going to be a minus 5x. All right, repeat the process. Negative 5x times our entire divisor. So negative 5x squared minus 25x. Again, I'm going to put parentheses around this. We are subtracting that. Negative 5x squared minus a negative 5x squared. That's 0, as it should be. Negative 17x minus a negative 25. So that becomes plus 25x That gets us to be an 8x. Bring down the 32 that we didn't mess with. All right. Now, you keep on repeating this process until this right here, we consider that our remainder. After you do the subtraction, whatever you get, we consider that our remainder. The rules of dividing by polynomials say that you keep doing this process until the degree of the remainder. Right now it's a degree 1 because it's an x to the first. You keep doing this process until the degree of the remainder is less than the degree of what you're dividing by. Right now it's the same. So what that means is we do it one more time. X times something gets us 8x. It's got to be a positive 8. So 8 times x is 8x plus 8 times 5. And we are subtracting. 8x minus 8x is 0. 32 minus 40 is a negative 8. This is our remainder. Okay, it is a degree 0 remainder. This is a degree 1 divisor, so our remainder has a smaller degree than what we're dividing by. That means we're done. Okay, so now, what's our answer? So we got a couple of ways to write this. If you were in my class, we did this. Our quotient was this stuff up top. X squared minus 5x plus 8. And then I just had you write the remainder polynomial. Negative 8. There's nothing wrong with this. There is another way to write your answer. And it kind of comes from, I'm going to just give you a real quick number example. If we did 16 divided by 5, 5 goes into 16 3 full times. That's that quotient. How many times is it going in there? It's got a remainder of 1. So 16/5, the way we would normally write this, it is 3 1/5. All right, that makes sense with numbers. We're going to do the same idea with our polynomials. So our answer, x squared minus 5x plus 8. Our remainder was a negative 8, so I'm going to go minus. Back to that number example. Our remainder was 1. 16 divided by 5, it's got a remainder of 1. So I'm going to put this remainder in the numerator over 5 was what we divided by. We divided by x plus 5. So I'm going to take that remainder of the negative 8 and put it over x plus 5. Okay, this is another way to write your answer. This is what you're going to see on the answer key. So there you go. All right, that's long division. The last thing we talked about with dividing polynomials is this idea of synthetic division. Synthetic division works only when we are dividing by a linear function and it's a coefficient of 1. So a 1x. Now, I say that even though there are some workarounds. If it was like a 3x, we could still do the synthetic division, but there's some extra steps. So for now, we're just going to keep it as you can only do synthetic division when you are dividing by a 1x function, a linear function of with a coefficient of 1. So synthetic division is convenient because it's quicker. The thing that so the setup of this, the thing that you are dividing by, we take the 0 of that. So meaning, if you set x minus 8 equal to 0, you'd get 8. We take 8 and we put it in this little corner here. You take your coefficients of what you are dividing into. So we have 8x to the 4th. We have negative 64x cubes. And I'm leaving a little bit of space between these numbers. Now, the other thing with synthetic division, notice how there are no x squared terms. With the long division, it was nice to have a placeholder. With synthetic division, you have to have a placeholder. If you don't have a placeholder, answer is wrong instantly. So we have 0x squareds. We got 3 x's, and we got our constant of negative 28. Again, leaving some space between all those coefficients. I'm going to leave some space underneath these. Draw a line. Okay, that's our setup process. Take your first coefficient, this 8, bring it down. We don't do anything with it yet. Then this 8, multiply it by this 8, it goes underneath the next number. Then we add. Negative 64 plus 64 is 0. Then we repeat the process. 8 times 0. Add. 0. Repeat. 8 times 0 is 0. Add. 3 plus 0 is 3. And repeat. 8 times 3 is 24. Add. Negative 28 plus 24 is a negative 4. Okay, that's the process. The answer, again, I'm going to write it in two different ways. The quotient. We took a degree 4 polynomial, this x to the fourth, and we divided it by a degree 1. So basically what we did was we took an x to the fourth and we divided it by x. That gets you x cubed. So for our answer, these numbers underneath this line, these are our coefficients. But we're going to start with a degree 3. So it is an 8x cubed. And then we just start going down the degrees or the powers of x. So 8x cubed, 0x squared, 0x's, 3 is a constant. So plus, because it's positive 3. This last number here, the negative 4, that's our remainder. So we can write it this way. Again, on your answer sheet for the worksheet, you're going to see it written like this. Our coefficient, the q of x, 8x cubed plus 3. Our remainder is a negative 4, so we're going to go minus the remainder number over what we divided by, x minus 8. That's the way you're going to see the answer in, or on the answer key. That's dividing polynomials. All kinds of different ways to go about it. Some big ideas. When we talk about factoring and solving polynomials like we did in the first couple of weeks, we always wanted to have a remainder of 0. That's when we're trying to solve, when we're trying to do some factoring. You want the remainder to be 0. Does the remainder have to be 0? Absolutely not. It's nice. It means some things. We can do some things with it. But if the remainder is not 0, then so what? The remainder is not 0, and here's how we can write our answer. All right, I hope that helps. Have a great day.